there are a lot of different types of organic reactions, and we're going to look at a few of them here. One of the types of organic reactions that we've seen a lot of is combustion. Combustion is when you have fire. So in order for combustion to occur, we need some kind of fuel to burn. In this case, we're going to be talking about hydrocarbons, something that is hydrogen and carbon only. And in the presence of oxygen, it will burn and produce usually heat or energy or light or all of them, as well as CO2 and water. Complete combustion is when you have sufficient, just enough oxygen to allow this reaction to occur completely, and you do produce CO2 and water. If there isn't enough oxygen, this is seen if a fire is occurring in a house, you will instead produce carbon monoxide and water, which is obviously very dangerous. Another type of reaction is substitution. Substitution is exactly what it sounds like. One comes out, one goes in. So think about like a substitute teacher. If I wasn't in school one day, there'd be one person in my place. So in this case, we're looking at an alkane. Here's an alkane, a saturated hydrocarbon. And in this case, we have ethane right here. So ethane is now mixed with chlorine molecule. And you could see right here is where the hydrogen pops off and one of the chlorines comes and takes its place. And what's left over combines as HCl. So substitution is taking one off and putting one on. Addition, on the other hand, is similar to a synthesis reaction where everything is combined in the end. So in this case, we have an unsaturated hydrocarbon, a double or a triple bond. That bond breaks, and in this case, both bromines take the place of where the double bond was. So we broke the double bond and both bromines came in. It's an addition reaction, which means we end up with only one product. Esterification, it looks like a lot of different information that you're going to be seeing, but the key thing is we're making an ester. Okay, so we're making an ester. If you take a look, the ester group is this. From table R, you know that the C double bond OO, that functional group represents an ester. So if you were looking at a reaction and it looks all crazy like this one, and they don't tell you what's going on, if you see in the product an ester, then you have esterification. Saponification is making soap. I like to think about it, take those first four letters, rearrange them, you're making a soap. In this case, you could see what I've written as the basic reaction here. It looks kind of messy like this. The key thing is we're taking an inorganic base and an ester. Esters happen to be very smelly, like they smell like strawberries or pineapples. Those would be like natural esters. We would want to put that into something that makes soap because we like our soaps to smell good. So the key thing here, though, that I want you to know is saponification is making soap. Fermentation, you should have seen a lot of before. Fermentation is when an organism breaks down their nutrient, and specifically sugar. And in this case, I want to talk about the yeast. This is a living organism, yeast. And we actually use yeast for two different things in our lives. One of them is to make alcohol, and the other one is to make bread. So if you think about it for a moment, we are giving the yeast a food source, glucose, and as a result, it goes through respiration the way it does it anaerobically without oxygen, and it produces ethanol, that's alcohol, and because you should know it's an alcohol based on that ANOL ending, and carbon dioxide, which is what we use when we're making bread. If you think about a bread that we use yeast in, it has that nice puffy appearance at the end because the gas in the that's released by the yeast is making that bread puff out. Polymerization is really just when you add small molecules together. So we could talk about addition polymerization. You could see this reaction I've shown you here, but really what I want you to be able to identify is here's some monomers, some singles, and then look, we put them all into a chain. Just like this one here. So you're just linking. It's like taking some Legos and sticking them all together. And condensation polymerization, in the keyword condensation, hopefully you're thinking about water here. In order for condensation polymerization to occur, we need to take out water to now link the monomers. This would occur like if we had monosaccharides, maybe we went through digestion, we broke them down to monosaccharides, our sugar products, we broke them down to monosaccharides, and then we want to store them in our body somewhere. So we would want to store them in larger molecules. We would have to remove water to link them right here. You could see they're linked now. We removed water by condensation polymerization. And if we wanted to link a whole bunch of them together at each spot right here, we would need to remove water in order to link these together into one long polymer like starch.